Water and methane are both relatively small molecules. Water, 3 atoms, has a molar mass of around 18 grams per mole. Methane, 5 atoms and has a molar mass of about 20 grams per mole. So they're both about the same size. They're both small molecules, yet methane boils at negative 161 degrees Celsius, very, very low temperatures, while water boils at 100 degrees Celsius at standard pressure. So why does 261 degree difference, fairly similar size molecules, why are their boiling points so different? Well, it has to do with their intermolecular forces. So methane is CH4 is carbon, essential carbon bonded covalently to 4 other hydrogens. You can see the difference in electronegativity is it's slightly polar, but this molecule is symmetrical. It's tetrahedral, has a bond angle of 109.5 degrees. They're being pulled in 4 equal directions. So even though the individual single bonds are slightly polar, the molecule as a whole is a nonpolar molecule. So the only intermolecular forces it has, these dispersion forces. Let's contrast that with water, which is very different. Water has essential oxygen covalently bonded to 2 hydrogens, single bond each. And if you look here, the electronegativity difference on this Pauling scale is much greater. So these are very, very polar bonds. Not only that, this is a bent molecule, so the whole molecule as a whole is going to be polar. Oxygen does have 2 lone pairs like that. This one here is 104.5 degree. That's not very important to know. What is important is because this molecule is polar and oxygen is so much more electronegative than hydrogen, that sets up for hydrogen bonds. Right? And hydrogen bonds can be formed when hydrogen is covalently bonded to one of these 3 very electronegative elements, fluorine, oxygen, or nitrogen. And that's what we have here. This shared pair of electrons is going to be favored toward the oxygen side, causing the oxygen side to be slightly negative, and then the hydrogen side of water molecules to be slightly positive. When you have millions of these, you're going to get these hydrogen bond interactions between all the water molecules. These purple dots representing hydrogen bonds between water molecules. I'll just draw one more here. Here's another water molecule, and I think you see the pattern. Right, so these purple dots, they represent very strong intermolecular forces, specifically hydrogen bonds. So it's going to take a lot more energy to vaporize water because of those intermolecular forces.